this lesson, we work through an example in which we apply Newton's second law to solve a problem involving an inclined plane with friction. Here is the question. Richard uses a rope to pull a crate of mass 20 kilogram up along an inclined plane of 30 degrees. The tension in the rope is 147 newtons, and the coefficient of kinetic friction between the crate and the inclined plane is 0,1. We have to calculate the acceleration of the block. So what do we know? We know the mass, it's 20 kilograms. From that we know the weight of the crate. 20 times acceleration due to gravity. We know the angle of the plane, we know the pulling force up, the applied force up the slope, parallel to the slope, and we know that there is friction, and we're given the coefficient of that. So we draw a free body diagram of the situation. Weight downward, as I've already said, is 20 kilograms multiplied by acceleration due to gravity, 9,8. The applied force, which we can also call a tension because there's a rope, 147 newtons, and it's parallel to the slope. So because this object is moving up the slope, friction acts down the slope. Because friction always acts in the opposite direction to motion. We have the normal force. Notice that it acts perpendicular to the slope, which in this case is not equal and opposite to weight because of there being a slope rather than a horizontal surface. And also the magnitude of normal is less than the magnitude of weight because of there being a slope. Now, when we solve problems involving inclined planes, we need to simplify the situation to only include vectors that act along the slope, in other words, parallel to the slope, and into and out of the slope, perpendicular to the slope. So at the moment, weight is a problem because it is acting at an angle to the slope rather than parallel or perpendicular to the slope. So let's resolve weight into its components parallel and perpendicular to the slope. The component perpendicular to the slope is equal to the weight's magnitude, 20 times 9,8, times cos theta. Theta in this case is 30. The component of weight parallel to the slope is equal to weight times sine 30. So here's the entire free body diagram with the components of weight drawn in instead of weight. What are we asked to find out? We must find the acceleration of the block. How can we do that? Acceleration equals net force divided by mass. In this case, the acceleration happens parallel to the slope. It's going to be up the slope in the direction that the man is pulling the block. And so the net force that is relevant to the acceleration is the net force parallel to the slope. Now we know the mass of the crate. It's 20 kilograms. But we don't know that net force acting parallel to the slope. We need to find that out so that we can answer the question, in other words, solve for A. So how do we find the net force acting parallel to the slope? We focus only on the vectors which act parallel to the slope. And we can see that there are three of them. Tension up the slope, weight's parallel component down the slope, and friction down the slope. We choose one of these directions to be positive. Since the object is going to move up the slope, let's choose up the slope to be positive. So to find the net force acting on this object parallel to the slope, we add the forces up the slope and subtract from that the forces down the slope. Fnet parallel equals tension minus weight's parallel component minus friction. Now we know T and we know weight's parallel component, but we don't know friction. How do we find it? We know that friction equals the coefficient of friction multiplied by normal force. Since this block is moving, it's kinetic friction we're speaking about, and therefore also the coefficient of kinetic friction. We are given the coefficient of kinetic friction, but we are not given the normal force. So we need to find out the normal force so that we can find out the friction force. We know that perpendicular to the slope, the object is in equilibrium. How do we know that? It is not accelerating perpendicular to the slope. It's not either flying upwards in the air, nor is it sinking down into the inclined plane. It's not moving at all in that dimension. And if it's not moving at all perpendicular to the slope, it can't be accelerating perpendicular to the slope. So it is in equilibrium perpendicular to the slope. That means that all the forces acting perpendicularly on the object cancel one another's effects out. What are those forces? There are only two of them. Normal perpendicular out of the slope and weights perpendicular component into the slope. And the vector sum of those two is 0, which means that in magnitude, the normal and the weights component perpendicular into the slope are equal to one another. So the normal force is equal to 20 times 9,8 cos 30 degrees. Here's an overview of what we've just been discussing. In other words, of the entire strategy for solving this problem. We're asked acceleration, so we need to know the net force acting parallel to the slope. To do that, we need to find out the friction force acting on the object. And to do that, we need to find the normal force acting on the object. Use this strategy now to actually put in numbers at the relevant places and answer this question.